We are working with graph frames. We have two data sets, trips data set and stations data set. We are building graph from these two data sets and performing a few functions like showing the in degree, out degree, and applying motives and displaying the motives from the graph. And then we have the bonus questions to find the vertex degree, that is the sum of the in degree and out degree, and the most common destinations from location to location, and in degree by out degree ratios. Now let's see the code. Here we have the dataset, trip dataset and stations dataset. Initially we are loading the dataset, trip dataset into the data frame trips underscore data frame. Similarly, we are loading stations dataset, which is of the format CSV file, into stations underscore df data frame. Here basically stations dataset contains the list of all the stations. Each station acts as vertex in the graph. Similarly, trips dataset contains the trips from particular source to destination. They typically form edges in the graph. Here we are initially displaying the schema of each data frame, trips data frame as well as stations data frame. And here we are to work on these two data frames, we are creating views for these. For the trips data frame, we are creating the view trips, and for station data frame, we are creating the view station. Here to select distinct columns, that is to eliminate duplicates from the stations, we are selecting only those stations that are unique, that are distinct. Similarly, we have n station, which is nothing but the stations. We are executing this particular view. Basically, we are storing all the data of stations in n station and all the data of trips in n trips. Here we are displaying all the vertices, station vertices, and then the trip edges. Here we have the n station, so we are selecting all the vertices in the n station, and we are renaming the column name as id. Similarly, we are in the trips, we have column names start station and end station. We are renaming those columns as source and destination and storing it in trip edges. Now we have the vertices and edges. Now we are building the graph using graph frame. Graph frame, it takes two parameters, that is the vertices and edges. Now we have the graph here. Here in the station data frame, we have two columns, that is latitude and longitude. So we are selecting the location basically of each station, that is we are selecting the latitude with the space of longitude, and we are naming that column, the combination of these two columns, as location, and we are displaying it, just the top 10 rows. From the station graph, we are displaying the number of vertices, number of distinct vertices, number of edges, number of distinct edges. Prior to building the graph, we have n trips. We are displaying the count on n trips as well. Since the graph is built using n trips, we will just have the same count for these two, the graphs and the n trips. Here we displayed the count of the vertices and edges. Here we displaying the vertices of the graph. Here we are displaying the edges. Vertices are nothing but the stations, edges are nothing but the stations, source and destination, that is nothing but the trips. To find the in degree of vertices in the graph, we have this parameter in degrees, that is we can directly apply on the graph. Here we have in degrees stored in dig. Now this will have id, that is nothing but the station and the in degree of the particular station. We are displaying the top 5 in degree vertices here. We are selecting that and showing them. Similarly, for the out degree of graph vertices, we are finding the out degree and displaying the top 5, or descending order and displaying the top 5. Again, the motives in the station graph, we are displaying only those edges that are bidirectional. That is, if we say there are two vertices in the graph E and B, if We are displaying the motifs of the graph which are in the pattern edge from A to B and edge from B to A. That is, if a edge is bidirectional between the vertices A and B, we are selecting all those motifs and we are displaying it over here. Similarly, this is the bonus question here. Here we are finding the degree. Degree is nothing but the sum of in degree and out degree at a particular station. So we are calculating the in degree and displaying the top 5 degrees in the graph. And to find the highest destinations from location to location, we are grouping by source. In the station graph, we are grouping by source and then by destination, and then we are ordering in the descending order to display the top 10 destinations from location to location. We are displaying it over here. And to find the in degree by out degree ratio, we have in degree computed here and we have out degree computed here. We are joining these two tables. We can say these two tables have a common column ID, that is nothing but the station. We are joining these two tables on the column ID, where in degree dot column of ID equals out degree dot column of ID. And since we have these two columns, we are eliminating one duplicate column, that is we are dropping out out degree dot column of ID. The select expression is we are selecting the stations and the ratio of in degree by out degree as degree ratio. Since we need those stations with highest in degree and lowest out degree, we are ordering this in descending order and showing top 10. Now let's execute this particular program. So here you can see this is the train data, that is the trips data schema and station schema. Trips have a station, start station and end station. Similarly for the stations, we have the station name and the dog count. We are selecting the distinct dog count, just the top distinct. And here this is the location. We joined latitude and longitude and displaying it as a location over here. This is the number of stations, distinct stations, number of trips and distinct trips. This is from the graph, and this is from the original data trips. Since the graph is built using the trips data, we have same number of trips both in graph and the original data. Now these are the vertices and these are the edges. And here we are displaying the in degree. These are the vertices of the graph, that is nothing but the stations, and their in degree, that is number of trips with destination as this particular station. And here the out degree, the station and the count of out degree, that is number of trips with start vertex as this particular station. Here we have the motives being displayed. So these routes are bidirectional, that is there is a trip from A to B as well as from B to A. Here this is the degree, that is the sum of in degree and out degree. And here is the degree ratio for the particular station, in degree by out degree. This is the degree ratio. This is all about this ICP.